Alright, ladies and gentlemen, this is a short video that I'm making due to the activity we did in class today on polygons in the coordinate plane. This was meant to be a group activity and some students were absent, and I want to give them a chance to understand the key components of this activity. And the main goal here is to be able to find lengths of line segments in a coordinate plane. So I know you have this assignment at home, so I'm just going to go through this so you kind of have an understanding of what the expectations were with this. So the first part showed a coordinate grid, and it asked you to plot and label the points for the public library at 4, 5. Now we know when we plot on a coordinate grid, we're going to go over 4 and then up 5 using the X and the Y coordinates. And it does say to label those points. So this would be the library. I'm going to label that with an LIB. Okay, and then I'm going to plot the City Hall, which is at 7, 5. That's over 7 and up 5. So I've done part A, plotted and labeled those points. I'm going to label this with a CH for City Hall. Now, it says, how far is the public library from City Hall? Now, this is a linear measurement. You can see right here that that's 3 miles away. Now, I know it's miles because it says in the direction that each square on the grid represents 1 square mile. So this is going to be 3 miles away. Now that's a linear measurement because it's a distance. So even though each square represents 1 grid, it's not 3 squares away, it's 3 miles away. So a stadium is located 4 miles from the library. They want us to give the coordinates of several possible locations of the stadium. Justify your answers by graphing. So I'm going to go ahead and graph first. I can see that if I'm going from the library, I'm going south 1, 2, 3, 4 miles. That could be the location of the stadium. If I'm going north 1, 2, 3, 4 miles, that could be the location of the stadium. Or if I'm going west 1, 2, 3, 4, that could be the location of the stadium. Obviously, it could be here as well. But those are the 3 that I use. So I'm going to go ahead and write the coordinates because it does tell me to give those coordinates of those locations. So the coordinate here would be 0, 5. Here would be 4, 1. And this would be 4, 9. So I've completed letter C. Now it wants us to connect the 3 locations of the public library, City Hall, and the stadium. So I'm going to go ahead and use this version of the stadium. And you can see that that makes the shape of a triangle. Okay. And I'm going to go ahead and use a highlighter. It's probably going to smear my black ink here. And connect the City Hall, the library, as well as the other location for City Hall. And you can see that just makes a straight line. All right, those are the shapes that I can form. I could have formed another triangle as well. All right, so we're going to move on to the next activity. We've completed activity 1. And it says, work with a partner, plot and label each set of points in the coordinate plane, then connect each set of points to form a polygon. So it tells us it's a rectangle. It's really important when you plot these to label them with the letters as you go, so you don't need to go back and spend your time finding those. So we're going to go ahead and right away find point A would be over 2 up 3. That's point A. Then over 2 up 10 is point B. Over 6 up 10 is point C, and over 6 up 3 will be point D. And you can very clearly see as I connect those points, this is indeed a rectangle as the direction stated. Now I'm going to go ahead and plot the points for the triangle. So that's 8, 3 would be letter E. 14, 8, which would be right here for letter F. And 14, 3 for letter G. And then since it's the last point, I can connect it back to make my triangle. So I've completed this part of activity 2. Now, activity 3 is actually going to rely on using this picture. So I'm going to grab another copy of this worksheet. And so here we go. Now we'll be able to see the picture as well as the direction here. All right. And so it asks us to find the length of each horizontal line segment in activity 2. I'm going to actually use this orange pen to trace the horizontal line segments. Okay. And after I've traced them, I'm going to find the lengths of each of those. So this is 4. this is 4, and this is 6. Okay, I can just count those to see. So the answers here would be 4, 4, and 6. And it wants to know what relationship do you notice between the lengths of the line segments and the coordinates of their endpoints. So here's an example of a line segment, BC. All right, and let's look at the coordinates of B and C. And if you'll recall, the length of that line segment was 4. And so what they want to know is what relationship do these coordinates and the number 4 have to do. And you probably noticed the same thing I noticed, is that the 10s were the same, but the 6 and the 2 were different. In fact, the difference of 6 and 2 is 4. So I subtract 6 and 2, it's 4. And you could probably assume the same thing will happen with A and D, but we could check 2, 3, 6, 3, and sure enough, that makes sense. And let's take a look at DG. So line segment DG would be 6, EG. That'd be 8, 3, and 14, 3. And you can see when I subtract 14 and 8, I do get 6, which is the length here. So the relationship we've realized is that the difference of the coordinates is the distance. So basically, if you subtract your unlike coordinates, you're going to find out your distance. All right, and what's interesting is when we asked to do part C, it's basically the same thing. Now they're asking us to look at the vertical line segments. And you're going to notice that that same quality happens. So we can just use FG as our example. So FG would be 14, 8 and 14, 3. And the difference between 8 and 3 is 5. And look at this, 1, 2, 3, 4, 5. So that proves that that works. So the same thing here. So if this is 5 and this is 1, 2, 3, 4, 5, 6, 7, all right, then so it's 5, 7, and 7 would be my answers to here. And then my answer here will be the same thing. I'm going to use different words to explain the same thing. And I'm just going to write if you subtract the coordinates, you get the distance. And so again, this pretty much answers our question. Okay? And I'm sorry my handwriting wasn't as neat because I was on the edge of the desk there. So when we move on to the next section, it's the same basic concept, but they want to see if we can apply it with a new set of questions. So it says plot and label the points below in the coordinate plane. Then connect each pair of points with a line segment. Use the relationship you discovered in parts B and D above to find the length of each line segment. Show your work. So they want us to plot the points in the coordinate plane. So I'm going to start with ST. So that's over 3, up 1, and over 14, up 1. And those are points S and T, and I'll connect them with a line segment. Then I'll do UV, which is 9, 8, and 9, 0. And then I've got WX, which is 0, 7, and 0, 10. And then finally YZ, which is 1, 9, and 7, 9. All right, very good. So I've plotted those points. Now, then they wanted me to use the relationship we discovered. So the relationship we discovered is these numbers are the same. So if I subtract 14 and 3, that gives me 11. If I subtract 8 and 0, that gives me 8. Again, the 7 and the 10 are different, so I subtract those to get 3. And again, the 9s are the same, so now I'm going to subtract the 7 and the 1 to get 6. So these should be the lengths of these lines. And now it wants me to check my answers by counting the grid lines. So let's look at ST. We expect the answer to be 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That one worked. Let's take a look at this one. UV should be 8. Let's find UV. 1, 2, 3, 4, 5, 6, 7, 8. Yep, that one worked. WX should be 3. 1, 2, 3. Yep, that works. And YZ should be 6. Let's check it out. 1, 2, 3, 4, 5, 6. That works as well. So we're good on that. Now, in our own words, and obviously I really want this to be in your own words, but the idea is, how can we find the lengths of line segments in the coordinate plane? The simple answer would be just to count them. But in a situation where that line is really long, it sure is nice to know that we can have a more efficient way of doing this. So what do we do up here? We subtracted the x coordinates. But then in the second example, we subtracted the y coordinates. So I think the real focus should be, if the x coordinates are alike, then you subtract the y coordinates to figure out the distance. And if the y coordinates are alike, then you subtract the x coordinates to find your distance. So I'm going to go ahead and I'm going to write that now. So if x coordinates are alike, subtract y coordinate. If y coordinates are alike, subtract x coordinates. So that pretty much answers our question. The only thing we're left really is with, do the methods you used in Activity 3 work for diagonal line segments? Guys, the answer is no, they don't. And the reason is, if I've got a diagonal line segment, like for example this one, look at my coordinates. This would be 11, 6, and this one would be 13, 10. The reason it doesn't work, they don't have any common coordinates. All right, and so that's basically it. So if we go back to our essential question here, which is, how can you find the lengths of line segments in a coordinate plane? We answered that here, okay? You can, if your x coordinates are alike, you'd subtract your y coordinates. And if your y coordinates are alike, you subtract your x coordinates. So I do feel like we understand that from doing this example. I hope that by you going back and redoing it, you will fully understand this and be ready for the next phase of our lessons. Thank you.